So in this video, we're going to talk about the System F IDE that was developed for the course. The IDE does a few things. It has tests that can pass or fail, as you see here, and we can run code. So a few ground rules here are that if we start the name in the IDE with a capital letter, as we have done here, it is a type. If we start with a lowercase letter, we are defining a term. So we can define the type ID to be for all A to A. And the term ID is defined as big lambda alpha, lambda x with type A, and it returns x. So notice big lambda is defined with slash backslash, and little lambda is just defined with backslash. So here on line 3, we are calling the identity function. As its type, we are passing in capital ID, and as its parameter, we are passing in itself. And notice our line 3 is evaluated here. It says eval normalize ID to lambda a lambda x.x. So here we didn't explicitly define the lambda because the ID is able to infer it for us. Another thing to note here is that if we are specifying a term, for example, here with 0, if we give it its type on the left side of the equals, then we don't have to explicitly enter it here for lambda. All right, let's go ahead and define capital B bool and say that for all alpha capital A, So this is our definition of a Boolean. Okay, let us define the type true, which is a bool. And we have uppercase lambda A, lowercase lambda x A, and then we are saying for lowercase lambda y type A, we're going to return x. Similarly, we're going to return y for false. And then now we can define not and say lowercase lambda b type bool, b bool, return f if something was true, false if it was false, return true. And now we can test not. So not t is f, and not f is t. Next, we can go ahead and define and. And before we move on to our next example, allow me to show you that since we annotated our types, type bool, and before we move on to our next example, allow me to show you what I mentioned earlier, that if we annotate our types on the left side of the equal sign, the IDE allows us to not enter them, and it just implicitly infers them. Now let's look at an example of and. We defined and bool arrow bool arrow bool because it takes two bools and returns a bool. And then we are saying this lambda b1, lambda b2, such that b1 bool b2 f is and. Let's test this. Okay, and all our tests pass here. Let's go ahead and implement OR. And the difference with OR is that we put a true here and take false out. Okay, let's go ahead and test OR. All right. So here's our definition of OR and the tests. All right, let's do a final example of if, but since if is defined in this language, I'm going to name it slightly differently. So we're going to say for all alpha and input bool and true of any type alpha, we're going to return one of those alphas. So that's our definition. And we're going to say that lambda, capital lambda alpha, lowercase lambda b of type bool, and our first lambda a1 of type alpha, a2 of type alpha, evaluate b1, and then return a1 or a2 of type alpha. Oh, and this should actually be b. Okay, so let's write some tests and use some variables we have. Test t 0, 1, 0. Sorry, I have to say that this is if, and we pass in type nat. And then the second test, we can just pass in false, and that would give us 1. All right, and this way we have implemented if, or, and not in system F. All right, and that's it for this video.